All right, 4.5, solve quadratic equations. By finding square roots. So to start out with, we're just simplifying radical expressions. So something like the square root of 192. We're basically just going to be breaking this down until we get it as simple as possible. So the easiest way to do this is to do like a little factor tree and break this down into pieces. So 2 and 96. And you can obviously break it down different ways, but then that would be 2 and, or wait, let's do it this way. 3 and 32. That's 2 and 16. That's 4 and 4. And then each of those are 2 and 2. And so we have to take things out in, since it's a square root, in groups of 2. So I've got a group of 2 here, a group of 2 here, and another group of 2, and then I have a 3 all by itself, so that's what gets left inside. So I've got 2 times 2 times 2, so that's each pair getting taken out, times the square root of 3, so anything that didn't have a pair with it gets left inside. And so this would be 8 square root of 3 would be how that gets reduced. So now that's just if they give you just a radical and then some number under it. Sometimes they'll also give you something like the square root of 3 times the square root of 27. And so when you multiply square roots, okay, we can multiply what's inside of them. So this would be the same thing as the square root of 3 times 27. And what's 3 times 27? 81. So the square root of 81 we know is 9. So we don't even need to break it down to be able to do that. Now, the other option, if you got something where, say, you didn't know what it was, you could start your factor tree from right there at 3 and 27, because ultimately you're trying to break it down. That's 3 and 9, and then 3 and 3, and you could have gotten there the same way, but that was one that we knew. Eight, 5 square root of 24 times 3 square root of 10. So similar to number 6, I can multiply what's in the radicals. The stuff that's outside will just get multiplied together. So that's going to end up being 15 times the square root of 24 times 10. And then I would just go straight from there to break it down. So 10 is 2 and 5. 24 is 3 and 8. Obviously, there's other ways you can break it down. 2 and 4, which is 2 and 2. So I have 1 set of 2s, 2 set of 2s, and then I have a 3 and a 5 left over. So that's going to end up being 15 times 2 times 2 times the square root of 3 times 5 is 15. Now, you wouldn't need to write this intermediate step. You could just go straight to it. I'm just doing it for reference for you, but that would be 60 square root of 15 for that one. You have a question?
Yeah, what about the... Oh, no, could you finish it further?
And if at any point you get to something that you already know is like a perfect square, like let's say like on one side we had a 16, just go ahead and do that as 4 and 4 and just take out a 4. Like you don't need to actually factor it all the way down. The factor tree is really just to help you make sure that you get all the pieces of it, but I will stop when I get to something that I know is like already a perfect square because there's no reason to keep going. It's just excessive. Now, if we have the square root of 35 over 36, so everything is under the radical, I am allowed to split it up into two separate ones. And so this would be the square root of 35 over the square root of 36. Now, a couple things about this. I can never, ever leave a radical in the denominator. Okay, so I'll have to rationalize it. In this case, I won't, because obviously 36 is a perfect square, but in the next problem that we'll do, I will have to rationalize it, because I can't have that there. In the top, it's fine if we are left with a radical. The bottom, it is not. So, square root of 36, we already know what that is. It is 6. Square root of 35, though, we need to see if it can break down, but that's just 7 and 5. That doesn't break down any farther. So we would just leave this as the square root of 35 over 6. (12) 7 over the square root of 12. So first thing, always see if there's anything we can factor out. Because again, I've got a square root on the bottom, which I know is going to ultimately be an issue. But 12 can break into what? 6 and 2. 6 breaks into 3 and 2. So I have a set of 2's that'll come out. So that leaves me with 7 over 2 square root of 3. Now I've got a radical on the bottom, which is a problem. So I'm going to multiply by the square root of 3 over the square root of 3. Because what that's doing is I'm multiplying by 1, right? It just looks different. But I'm going to get rid of that radical on the bottom by doing that. And so that's going to end up giving me on top 7 square root of 3. On the bottom 2. And then square root of 3 times the square root of 3 would just be the same as the square root of 9 under the radical. So that's going to be 2 times 3, which is 6. Okay, now if at that point something could reduce, like if that 7 had been something that would reduce with 6, I would reduce it, but it's not, so it'll just be left there. (14) square root of 13 over 28. So what do I need to do with this one?
Square root of 13 over square root of 28.
Yep, so first split it up into two separate radicals. And then what?
Factor. Well, 13 is a common number, so factor 28.
Yep, so square root of 13 is going to stay. So 28 is 7 and 4, which is then 2 and 2. So 2 square root of 7 on the bottom. Now what?
Multiply by square root of 7 over square root of 7.
Yep. Multiply by square root of 7 over square root of 7.
Square root of 13 times 7. And then the square root of 2 times, or over 2 times 7.
Yeah, that ends up being 91 on top. And then 2 times 7 is 14. So square root of 91 over 14. All right, so we're going to get into some that are a little harder now. You're probably bored with these by now. So 16, 1 over 5 plus the square root of 6. So first and foremost, can anything come out of the square root of 6?
2 and 3.
So nothing can come out. Yeah, so it factors into 2 and 3, yeah, but nothing can come out. So what might I need to do now?
Multiply by the square root of 6 over square root of 6.
So if I do that, don't write this down. If I do this, I'm going to get square root of 6 on top over 5 square root of 6 plus 6. So what's the problem?
It's still a square root.
Still have a square root on the bottom. So that's a common mistake. That's why I like to ask what you think we need to do, because now you'll know don't do that. And that's why I also tell you don't write that down, because people tend to do that. So what we actually multiply by in this case is the conjugate. Okay? So the conjugate is whatever this is, but we change the sign, because then that gives us, well, when I write it, you'll see what it is. Or we'll see if it looks like something to you. What does this look like? 5 plus the square root of 6 times 5 minus the square root of 6. The one thing that we did. It was a special type of factoring, which is what?
Perfect square binomial.
Nope.
Difference of squares.
Difference of squares. Okay? So difference of squares, which means that that middle term that's going to be left with square roots is going to cancel. Okay? So on top, I have 5 minus the square root of 6 over 25 minus, okay, because that middle term's going away. So then I have square root of 6 times negative square root of 6, which is just going to be minus 6. So this is going to reduce to 5 minus the square root of 6 over the, nope, not square root, over 19. And then I'm good because I have no square roots left on the bottom. Now, get a little harder. 18. 3 plus the square root of 7 over 2 minus the square root of 10. So anytime we have the square root on the bottom, we still always want to check and see if something can come out first before we do it. Can anything come out of, well, either the square root of 7 or the square root of 10? No. So I've got, again, 2 minus the square root of 10, so I need to multiply by the conjugate, which is going to be 2 plus the square root of 10, so it's always got to be the opposite sign. So 2 plus the square root of 10 over 2 plus the square root of 10. Now, on the top, okay, I'm foiling. So 3 times 2 is 6, plus 3 times square root of 10 is 3 root 10. Square root of 7 times 2 is 2 square root of 7. And then square root of 7 times the square root of 10 is the square root of 70, which I can't take anything out of that either because 7 and 10 don't have anything in common. And then on the bottom, difference of squares, so that's going to be 4 minus 10. So on top, if there's ever anything that I can simplify, I will. In this case, it's kind of ugly, so there's nothing that I can simplify. So this just ends up being 6 plus 3 square root of 10 plus 2 square root of 7 plus the square root of 70 over negative 6. So sometimes they come out a little nicer than that, other times not so much. The only scenario that you'll really see with these that we didn't have in a example problem is if there's like just a square root of like say 5 on top. In that case, when you multiply by the conjugate, you're just distributing on the top. So that is the only thing that might happen. With that, let's see, just a couple more. Actually getting into solving equations that have square roots. So when we take the square root of an equation, how many answers do I have? 2. What are the 2 options? Yeah, positive and negative. So 22 s squared equals 169. So I take the square root of both sides. So s equals what? Positive or negative 13. Now, I had a professor in college that got mad at us writing it like this because he was like, it can't be both at the same time. So the first year teaching, I was like adamant that people write them separately. I don't care that much. You can write them together. But a lot of times you'll see it as this. So either way is fine. if you're going to be a math major in college, you might want to get used to writing it this way. And if you're not, then you can just write it this way. 24. X squared equals 84. What do I do? I gotta take the square root of both sides, right? So x equals plus or minus the square root of 84. Is 84 a perfect square?
No.
So I'm gonna see if I can break it down. What can I break it into? What'd you say?
7.
7? Did you say 6 or 7? Okay. I heard you wrong. I was like, 12 and 6 doesn't work. 12 and 7. 12 breaks into. And then 4 is 2 and 2. So that means I can take out a 2 and be left with 21 inside. So x is equal to plus or minus 2 root 21. All right. 28. So now actually getting into having to like legitimately solve equations. 7r squared minus 10 equals 25. So I'm basically just moving stuff over, dividing until I get down to just something by itself. So 7r squared equals, add the 10 over, 35. R squared equals 35 divided by 7, which is 5. So R equals plus or minus the square root of 5. All right, last one. 32. 7 times x minus 4 squared minus 18 equals 10. Now, I don't think this problem particularly is that hard, but for some reason people tend to get confused on the process by which to do this problem. First and foremost, we add the 18 over. So we have 7 times x minus 4 squared equals 28. Then I divide by 7. So x minus 4 squared equals 4. Now, this is where people tend to get confused for whatever reason. They try to add the 4 out of this squared term. We can't do that, okay? That whole piece is being squared. So this is like saying x minus 4 times x minus 4 is equal to 4, okay? So we've got to take the square root first. So that means we have x minus 4 is equal to plus or minus 2. Now at this point we do have to actually split it into 2 separate equations, okay, because there's another step that needs to be done after this. So we're going to have x minus 4 equals 2, x minus 4 equals negative 2. So when we add the 4 over, that gives us x equals 6 or x equals positive 2. And so those 2 would be my answer. Okay, so that's 2 completely different answers. We can't just like lump that into one thing. So I don't think this problem is that bad, but people for some reason get very confused with this problem or problems like these and end up doing the process like completely backwards. It still follows normal PEMDAS rules of like undoing things. So y'all are pretty smart. I don't think this will be an issue, but just saying. It happens pretty much every year. So I like to point it out. Any questions about these? All right, then your problems, which if you don't finish today, you can finish them tomorrow since, you know, we're not really doing anything tomorrow. 3, 7, 9, 11, 17, 23, 27, and 31. I don't think they'll take you that long to do, but anyways. So tomorrow you'll have time to work on these problems if you don't finish them now, or if you have something you need to like study for right now and you're going to do them tomorrow. I don't really care as long as they're done by the end of class tomorrow. But tomorrow will also be time if you haven't done like the notes for the chapter, you could do that. You'll need 4.6 next Monday. So if you don't have those notes done, I would say do those tomorrow in class, so that way you don't have to worry about it over break. But beyond that, that's it.